Hi everyone. Today we'll learn two-pointer approach technique where most beginners solve pair problems using two loops. They write one loop inside another loop and the complexity becomes O of n square. But what if I tell you you can remove one entire loop and solve the same problem in O of n time? Today I am going to teach you one of the most powerful interview techniques, that is two-pointer approach. So let it write me two-pointer technique. O of n. So but we are looking at O of n today. Let's take a simple example. We are given a sorted array 1 comma 2 comma 4 comma 6 comma 8 comma 9 and the target equal to 11. Our goal is to find two numbers that add up to 11. Now, most beginners will do this. They will take two loops for I equal to 0, I less than n, I plus plus. Then they will take the nested loop for j equal to I plus 1 and I less than equal to n, I plus plus. Correct. That checks every possible pair and that works. But it's inefficient, correct? Because it takes O of n square of time complexity. So this is the brute force approach they used to follow. So next we, instead of checking everything, we use intelligence. We place one pointer at the beginning and one pointer at the end. Correct. So one pointer at beginning, which is L, and the one pointer at end. Here L equals to 1 and R equals to 9. These are two fingers. Now we calculate the sum. Here 1 plus 9 equal to 10. Now we'll check, is this 10 is equal to 11? No. Is it smaller or bigger than target? Greater or target? Yes, it is smaller, correct? So now here the core logic comes into picture for two-pointer approach. Let me write it down. If sum less than target, move left pointer, or if sum is greater than target, move right pointer. This is the entire brain of the algorithm. If the sum is too small, we move left pointer forward. And we can ask why, correct? So because the array is sorted in our case, and moving the left pointer forward increases the sum value. and if the sum is too big, we move the right pointer backwards. That decreases the sum. This only works because the array is sorted in our case. So here you can see 1 2 4 6 9 8 9, and this is sorted array, and sorted array is power, correct? So let's continue. Now we'll move the left pointer to the right. So let me write. So now our left pointer is on 2 and right pointer is on 9. So we'll repeat the calculation again. So L equals to 2 here, R equals to 9. So 2 plus 9 equal to L1. Boom, we found it. So our target is matching to our sum. So here 2 and 9 are our numbers, and these are our indices or indexes. So here we can see no unnecessary comparisons, no nested loops. It's just a smart movement. Now let's understand something important. How many times can the left pointer move? At most n times, correct? And how many times can the right pointer move? At most n times, correct? So but they never reset. Each pointer moves only one direction. So total operation become linear here. That's why time complexity equals to O of n, correct? So this is the major thing. So next comes, when should you think of two-pointer approach, correct? When should you think about this pattern? Ask yourself. The first thing is the array sorted, or I am looking for pair or triplet, or can I reduce space gradually? If you find as an S for any of these questions, then we can use two-pointer approach to solve the problem. Next comes, there are advanced techniques or variations we can say for the two-pointer approach. One first is opposite direction pointer. Second, fast and slow pointer, which used in linked lists to detect cycles. And finally, sliding window for subarray problems. So usually great programmers don't just solve problems, they recognize patterns, and two-pointer is one of the most powerful patterns you must master for coding interviews. So let's recap once what we did. So firstly, we are trying to solve complexity of O of n. So we have a given an array and our target is 11. So our brute force approach is use two loops and try to find the sum, and the third we use two pointer approach where our left pointer points to first and the right pointer as the end. So and we calculate the sum and our sum is not equal, then we come to core logic of the two pointer approach. If sum is less than target, then move the left pointer. If the sum is greater than target, then move the right. So in our case array was sorted, so we moved the left pointer again and calculated the sum and we found the number and we achieved time complexity of O of n. And we learned when to use the two pointer approach technique and variations of the two pointer approach. So if this helped you understand it clearly, make sure you practice it with problems like two sum, three sum, container with most water, or remove duplicates. So, and I will see you in the next video. Bye. Happy learning.